Hey y'all, so today we're going to be looking at graphing the sine and cosine functions. And so the first thing we want to look at is how do we get the points on the graph to make the graph. So we're going to look at our unit circle and figure out what does the sine equal at each point. And remember, sine is your y value. So at negative 2 pi, the sine is 0. So that is a point, negative 2 pi, comma 0. And you can see that right here. At negative 7 pi over 4, our sine value is root 2 over 2. So again, negative 7 pi over 4, comma root 2 over 2. That's a point, and which is right there. At the sine of negative 3 pi over 2 is 1. That's that value. And then you keep going through, just labeling points, finding your points, and you end up with all these dots, and you connect them with a smooth, curved line. So that's how we find the points to plot them and then draw our line. So that's how you get the graph. Next, looking at cosine, we're going to do the same thing. The cosine is your x value. So your x. We're looking at the graph y equals cosine of x. But remember, cosine is your x value on your unit circle. So let's go take a look at the cosine of negative 2 pi. That's 1. So that's a point. So negative 2 pi, comma 1. And then plot that point. There is at negative 7 pi over 4, the cosine is root 2 over 2. At negative 3 pi over 2, our cosine is 0, and then so on, plotting our points, marking them, and then again, connect it with a smooth, curved line. Okay. All right, so next we're going to look at the properties of these graphs. So taking a look at them both, they both go on in the x direction, in the negative and the positive direction forever. It's continuous. So the domain is all real numbers. On both the sine and the cosine, our graph's minimum value is negative 1, and the positive y value is 1. So our lowest y value and our highest y value on both graphs is negative 1 and 1. So our range is between negative 1 and 1. Next is just identifying if it's an even or odd function. In this we learned in 6.3, sine is odd and cosine is even. And then we also learned that they both have a period of 2 pi. So every 2 pi on this graph, we're going to repeat what the graph looks like. Okay, looking at the x-intercept for sine, it is, we go and find our x-intercept right here at pi. Then the next one's at 2 pi. There was one at 0. There's one at negative pi and negative 2 pi. And the distance between each of these is pi. So our x-intercept is pi plus pi k, because the distance between each one is pi. So we can get an x-intercept every time we add pi to the first one. Okay, and then for cosine, we have that x-intercept of pi over 2 and 3 pi over 2, and then there's negative pi over 2 and negative 3 pi over 2. And again, these are a distance of pi away, so every time you add pi, you're going to get to another x-intercept to pi over 2. Okay, so our y-intercept on sine is 0, 0. So the y-intercept is 0. And then on cosine, it is 0, 1. The maximum values are both 1, but they happen at different places. So at sine, it's pi over 2, happens that maximum point. And then the next time it happens, if we go in the opposite direction, is at negative 3 pi over 2. And the distance between pi over 2 and negative 3 pi over 2 is a total of 2 pi. So if you take that 3 pi over 2 or pi over 2 and add 2 pi, you will get to another maximum value. And then for cosine, we have that maximum value at 0, 1. And every time, again, we'll add, the next time it happens is at 2 pi, and that is 2 pi away. So we have a maximum value at 1, and then every time we add 0, it happens at 0 of a maximum value of 1, and every time we add 2 pi, we will get to that maximum value again. And then looking at the minimums, so at sine, the minimum value is at 3 pi over 2, and then again, the distance between negative pi over 2 and 3 pi over 2 is a total of 2 pi. And then the minimum values for cosine happen at pi and to negative pi, and that's a total distance of 2 pi from each other. So the minimum values are -1 at pi, and then anytime you add 2 pi, you will reach another minimum value. Okay, so now let's look at if we have transformations. How do we graph these graphs? So here's just what each part of the equations mean. So the A value is your amplitude, and this just tells you how tall or short this is going to be. And you find it by doing the absolute value of the A value. And then the next is our period, and you find it by doing 2 pi divided by W. And this just tells you if this is going to have a horizontal stretch and a change in it. Then if that A value was negative, there's a reflection over the x-axis. And then if there's a plus B, which would happen outside of the parentheses, would be a vertical shift, so if it moved up or down. So to the right is the steps 1 through 6 of how to draw your graph. So we will be using those in the next couple examples. But the first example, we are just going to find the amplitude and the period. So first, let's find the amplitude, and to get that, it's the absolute value of A. So here we have an A value of 3, and so the absolute value of 3 equals 3. So our amplitude is 3. Next, for period, we do 2 pi divided by W. And right for this one, there's a 1 technically in front of that x. So our W is 1. So doing 2 pi divided by W equals just 2 pi. So there's no change in this period because the cosine's period is 2 pi. And that makes sense because it was just cosine x. Next, we're looking at 4/3 sine times the 2/3 times x. So getting the amplitude, it's the absolute value of 4/3, which equals 4/3. And then to get the period, we're going to do 2 pi divided by 2/3. So we need to multiply by the reciprocal. Those 2's cancel. So our period is 3 pi. And then that's it for those ones since we were asked not to graph. But for these next two, we are going to graph. So first step, determine the amplitude, period, vertical shift, and if there's a reflection. So again, we have an A value of 2 and we have a W of 1/2. So our amplitude is the absolute value of 2, which is 2. And then for our period, it's 2 pi divided by W, and then multiply by the reciprocal, so 2 pi over 1 times 2 over 1, which equals 4 pi. And remember, cosine's period is originally 2 pi without any changes, and now we're at 4 pi, so our period has doubled. Okay, next we are going to look at, we didn't have a B value, so we're just going to skip 2. And now we're going to start actually graphing this. So let's draw our graph here. And we only need to worry about the positive half. That's okay. So if we were to draw our original cosine graph, it was to look like this. I'll just draw our original first, and it goes to 2 pi. And this was, we want to always label 5 points. So this is pi over, at that x-intercept is pi over 2. This is pi, and then this is 3 pi over 2 at the other x-intercept. So that's our original y equals cosine x graph. So the next thing we want to do is draw our amplitude and add that on there. So it's getting, we're stretching it by 2. So now our amplitude is 2, so it's going to be taller. So now it's between 2 and negative 2. Then we're just going to redraw the same graph, just now taller. And still label that 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, and this was y equals 2 cosine x. All right, so now we have to take care of the period. And as I said in the beginning, our period doubled. So each of those different intervals are going to get doubled. So we're going to multiply each by 2. So same amplitude from negative 2 to 2. 0 times 2 is 0. And then pi over 2 times 2 equals pi. And then pi, our next piece, pi times 2 is 2 pi. And then 3 pi over 2 times 2 equals 3 pi. And then we already found that the period ended at 4 pi, or 2 pi times 2 is 4 pi. All right, and then we're just going to draw that same graph, but with our new intervals. I'm going to move this down. And so we're going to go down and back up. And this is y equals 2 cosine 1/2 x. That's it. Okay, so now to graph y equals negative 3 sine 2x plus 1, we're going to label all those points again. So we have the a value, the amplitude of the absolute value of negative 3, which equals 3. We know since a was negative that we're going to have a reflection. Next, the period, we have w equals 2. So 2 pi divided by 2 is pi. So our original period for sine is 2 pi, and now it's pi, so everything is going to get halved. And then we have a vertical shift of plus 1. Okay, so we did have that plus b value, so we're going to start by drawing that vertical shift on our graph. So let's start again, though, by graphing just the sine function to work off of. So we have 2 pi, 3 pi over 2. This is pi, and this is pi over 2, and that's 0, and it's from negative 1 to 1. So if there's a vertical shift up 1, we're going to have a new, we're going to be moving everything up 1. So 1, we're now going to be up to 2. And then we'll just label this negative 1. So we're going to now start at 1, go up to 2, and then down to 0, and then back up to 1, because it all shifted up 1. And then that turned into a straight line, but it was not supposed to. Down to 0, up to 2 pi. Okay, 2 pi. Label our points again, 3 pi over 2. And then there's pi, 2 pi, just pi over 2. Oops, pi over 2. Okay, that's with our vertical shift. So this is y equals sine x plus 1. All right, next is we are going to be adding in our amplitude. And so our amplitude is 3. So we need to add 3 units up and 3 units down. So if we're starting at 1, we need to add 3 units up. So 2, 3, 4. And then 0, -1, -2. Draw the same thing, but now we're going to go up to 4 and down to -2. So up to 4, and then, whoops, up to 4, down to -2. And then still back up to 1. And then label our points. So 2 pi, then we have 3 pi over 2, pi over 2, and 0. And then this was y equals 3 sine x plus 1. The next piece we're going to do is that period. And remember, everything is getting halved in this one. So we're still going to have that same amplitude of 1, 2, 3, 4, 0, -1, -2. And then everything is getting halved. So 2 pi divided by 2 is pi. 3 pi over 2 divided by 2, multiply by the reciprocal, is 3 pi over 4. Pi divided by 2 is just pi over 2. And then pi over 2 divided by 2 is pi over 4. So these are our new subintervals. And then we're just going to redraw what we drew. So we're going to go up, back down, back up to 1. And this is y equals 3 sine 1/2 x plus 1. So lastly, we just have to take care of the reflection. I'm going to redraw just what we just drew. So 1, 2, 3, 4, 0, -1, -2, pi over 4, pi over 2, 3 pi over 2, and pi. And I'm going to draw that. We go up, down, oops, up, down, up, up. Okay. So the reflection is, we're just going to draw it the opposite way of what it has now. So it's going to be down and up and down, back down. And then that is our reflection. So the orange line is y equals -3 sine 1/2 x plus 1. So the reflection, you just flip what you have. And that's it. Okay. Let me know if